Hello, this is the second part of the congruent triangles lesson. The learning goals for this lesson are: understand the angle psi and the hypotenuse-leg congruence theorems. Understand that angle and psi angle relationships do not prove congruence. And also learn how to use the triangle congruence theorems and postulates to solve problems. Previously, we saw these three postulates that prove congruency. The psi basically says that if two triangles share the same three sides, they are going to be congruent. The psi says that if two triangles share two common sides and the angle in between those two sides is also congruent, then the two triangles are congruent. And the psi says that if two triangles share two angles in common and the psi in between those angles is also congruent to each other, then the triangles are congruent. Now we're going to analyze the postulate angle psi, or AAS. Here we have two triangles, ABC and DEF. If angle A is congruent with angle D, and angle B is congruent with angle E, and psi BC is congruent with psi EF, we put tick marks to show congruency between these two sides, then the two triangles are congruent. Okay? Let's try to understand this property with this example here. So here we have two triangles that have a psi 5 in common and two angles also in common. Now, we can calculate this third angle because the third angle is going to be 180 minus these two angles here, minus the measurement of these two angles, okay? Because all three angles have to measure 180 together. Here, this angle is also going to be 180 minus the measurement of these two angles here. Since E and D, A and B are congruent, these two are going to be the same. So 180 minus these two is going to be equal to 180 minus these two angles here, because these angles are the same. So now that we have shown that this third angle is also congruent between the two triangles, we can say that, or we can focus on this part here. This part would be an angle, a psi, and an angle. This is an angle, a psi, and an angle. So by angle, psi, angle, we can say that these two triangles are congruent. So basically, the angle, psi theorem or postulate can be proven by angle, psi, angle postulate. Now let's go into the hypotenuse-leg congruence theorem. This theorem says that if two right triangles, again, right triangles meaning they both have 90 degrees, have a congruent hypotenuse, they both share the same hypotenuse, 5 and 5, and a congruent leg in common, both have 3 and 3 as a leg, then the triangles are congruent. So the reason why these two triangles would be congruent if they share a hypotenuse and a leg is because the other leg would be the same, because the other leg is calculated by a square root of hypotenuse square minus leg square, which in this case is 4. Okay? So by Pythagorean theorem, we know that the missing leg, right, can be calculated and will be the same because the hypotenuse and the other leg are the same. So by psi, these two triangles will be congruent. So the hypotenuse-leg congruency theorem can be proven using the psi postulate. Now, we have to be careful. Not all relationships prove congruency, okay? Here we have the relation of angle, angle, angle. These two triangles have the same angles, 40, 70, 70, 40, 70, 70. But they are not congruent. They have different dimensions. This is bigger than this. So having the same angles doesn't mean the triangles have to be congruent. Okay, the psi angle or SSA relationship does not prove congruence. So here we have two triangles. We see that they have a psi, and an angle, as the same psi and the other psi and an angle in common, right? So psi angle. So right now we copy and paste these two triangles. So they are congruent. Right now these two triangles are congruent. But the question is, every time this psi and this psi are in common, this side and this side are in common, and this angle and this angle are congruent, every time that happens, the two triangles are going to be congruent? The answer is no. And here's how we can show that. So you see, basically, I move this side here all the way here. It's the same side. However, you can tell that these two triangles, this big triangle here, ABC, and this smaller triangle, are not congruent. However, they have the same psi, and angle, psi, and angle in common. So the psi angle relationship does not necessarily prove congruency. Now we're going to finish this presentation with a practice problem. This practice problem, they are asking what information is needed to prove that a triangle DAE, right, which would be this triangle here, is congruent with a triangle CBE, which is this triangle here. So we need to see what information, what additional information to what we see here is necessary to prove that these two triangles are congruent. So what I see here is that these two triangles are right triangles. So since they are right triangles, we can use the hypotenuse-leg theorem that says that if the hypotenuse is the same, which it is, you see this tick mark here and this tick mark here, thus telling us that the hypotenuse of this right triangle is the same as the hypotenuse of this right triangle. It measures the same. So we just need one leg in common and we prove congruency. So it could be this leg that is congruent with this leg. That will be enough. So if AD is congruent with BC by the hypotenuse-leg congruence theorem, then the two triangles will be congruent. The other possibility is that the other leg is congruent to the other leg. So if AE and BE are congruent to each other, then by the same hypotenuse-leg congruence theorem, both triangles are congruent. Okay? So basically, every time you see a right triangle and a hypotenuse in common, you should be thinking, if I can show that one more leg is something in common, then the two triangles will be congruent. And that's all for this lesson. Thank you very much for the attention.